Okay, greetings and welcome again for everyone who is watching the series or my channel or any video on this channel. This is Sajjad Ghafouri once again with the start of a new bundle, which is an update for the questions that we need to review and discuss before you can take your CCNA 231 exam. Just in case you know me, or if you have seen a previous video, then you know that already what I'm doing and what I'm talking about. And just in case it was your first time, then this series is a third series that I would recommend after you finish a first two series in the beginning to prepare you to become a certified Cisco engineer for the CCNA exam or certificate. First series is in the playlist of this channel. This is the triple I channel of networking or for networking, only for courses of course. The first series you will find is the complete English course of the CCNA 231. It's about 85 videos with labs, slides, discussion, interpretation, comparing everything just like the blueprints of the new exam wants. The course is built 100% entirely on the new blueprints. This will take you up to 90. This will take a minimum of, actually the length of the videos is 29 hours. Okay, this is a total length. After that, there is another series which is a short series of only 3 videos called the Mega Lab. Currently, at the moment that I'm recording this video, there is only one lab that has been published on that series. The other 2 will be by next week, so that will be in a few days. Each lab will take like from 90 maybe up to 180 or 100 or maybe 150 minutes or such. This is all about implementing and configuring labs. Some extremely important protocols that are still used in the enterprises nowadays have been removed from the new CCNA, and some of them are not even mentioned in the CCNP, new CCNP enterprise. So I had to make this extra series of videos. It's already available in Arabic, by the way, but for the English version, it's still being recording. So you will find them in Arabic, and I'm also recording. I have published already one of them in English. You will find those protocols that have been removed, that they will be implemented and configured with a big environment, big lab. This lab will contain a minimum of 6 up to 8 different protocols. All of them have been submitted and done in one lab, and all of the network are operating and working normally by using all of these protocols, like DHCP, DHCP relay, HSRP because it has been removed. I will not implement VTP because I've talked about it a lot in the previous update. Also, there will be ROAS, SVI, extremely important, one area or multi-area OSPF, a lot of VLANs and accessing, trunking, etc. ROAS, I've talked about that also. Such things, yeah, this way. Okay, and the first one will be how we'll have 50% of it about manual subnetting with using some beautiful skills of CIDR and VLSM. It will be extremely important and beneficial for you in the real life networking, not for the exam, for real life networking. Okay, so this is the second series. The third series that I'm talking about right now is the exam prep. This is the series, this one. So far it has only 6 videos, which all of them were published back in April 2020, this year, 2020 April, like about 1 or 2 months ago. And it's all about everything you need to know about the online exam. Everything I must know before I enter that exam, so that in the exam I will do good. I will express and give my knowledge without getting confused, afraid, nervous, etc. Okay? And also it will discuss a lot of questions that you might see in the exam, might not, but all of them are extremely important and beneficial. Okay, so the past 6 videos have discussed almost 150 questions. Currently, at the end of May, I will produce 4 new videos. By mentioning that 6 videos will give you almost 150 questions. That gives an average of 25 questions per video. That's too much actually, because this 25 question per video is taking about 60 minutes to be done, sometimes more, sometimes less, like plus minus 10 minutes, but as an average it takes me an entire hour or 60 minutes to discuss 25 questions. So more than that will cause you headache, of course, surely. But you will enjoy this 1 hour. This is not about discussing new thing, because you have come to this series after you have finished and studied very well the previous complete course. So this is all about discussing and talking, chit chat, etc. Just talking. Yeah, what about the AD of OSPF? That's 110. Yeah, that's correct. Pass. This is a question. And this is a true question that you will face in the exam. It was in the previous exam, it's in Juniper's exams, it's in Huawei's exams, and you will see it in the new exam. These are the questions, the MCQs that you will see in the new exam. Okay? So I would recommend definitely to see the first videos of this series of the exam prep. There are 6 videos, and right now I'm producing 4 new. This means almost 100 new questions that will be discussed. Okay, so starting with today, this is about only 5-minute intro. I will start with today's video and with today's question, starting from question number 1, not question number 150 or 151, so on. The reason why is to separate the bundles of the time period that when this bundle of videos were published. And you will see the thumb saying that it's May part 1. The past 6 videos were April 1st, April 2nd video, April 3rd video until the April 6th. So these are past 6 videos, and starting from May, maybe you'd like only to study the first bundle of April, maybe you'd like to only to review this second bundle, because this is about discussing 100 questions, and in the exam you'll only see 100 questions almost in the real exam, in the real online exam. So this depends on you, on your maybe ability to absorb information, to review a lot of questions. Maybe from now up to the end of this year, there will be like a lot of bundles that it will cost even 500 questions. But it will always be April's update, May's update, June, July. I don't think it will be every month, to be honest, because April's update was discussing questions that were released back in February this year. But I did record and publish them in April because I was busy in February publishing the real course, the real complete course, which is the most important than just reviewing the exam. Okay. Right now, at the end of May, I'm publishing the bundle of May. It's not too late, believe me. Because since the questions of Feb was available and was beneficial for February, March, and April, I hope that the questions of May will be also beneficial and good enough to be studied for May, June, and July. So let's see, hopefully there will be no more updates until August or maybe the end of July. Okay, but anyway, to start with today, I will start with a new numbering of questions, starting from question 1 up to almost 110 or so, or such. Okay, so starting with today, this is question number 1. Let's see our pen. You have to pass to network 10.10.10.0, one that has a feasible distance. Whenever you see a feasible distance, an FD, this is one of the components that are this is one of the components of EIGRP's matrix, the protocol that's called EIGRP, which is the competitor of OSPF, but it's Cisco proprietary. So it was available later for other vendors, but no one bought it. But anyway, this is the competitor for it. It was removed from the CCNA course, but you just might see some questions in the online exam. The reason why is that 5 up to 10% of the online exam question might not be from the book. Okay, and might not be from the online. I'm sorry, it might not might not be from the blueprints. Just only 5 to 10% of the questions. This means 5 to 10 questions because the exam is almost 100 questions, the new exam. I will see more information in the first 2 videos of this series, for 1 and 2. Okay, so since that, there is this space for some tricky, challenging questions. You might see IGRP one of them, BGP, HSRP, BTP, MPLS, unfortunately and hopefully not, maybe PPP, point-to-point protocol. So these are some topics that all of them were PRIP, also ISIS. All of those guys were part of the no, not ISIS. Sorry. Yeah, this is joking. This is CCNA service provider. It was completely removed. Okay. Well, you'll just see ISIS as a word, but not really a big question on the theory of ISIS. So these are some 7 or maybe 8 protocols that were completely removed from the new CCNA, but you might see them in the real exam, and that's why this series is here. Okay, the series is also available in 2 languages. Whatever video for whatever reason you see in my channel, just be sure that this video will always be published in 2 languages, sooner or later, English and Arabic. Okay, so my channel is like a mirror. There is also the English and the reflect the Arabic, or vice versa. Anyway, so this series is already published in Arabic. Just in case you were curious and just want to see the videos in other language, you are in a hurry, it's already available in Arabic. Part number 1, 2, 3, and 4 for me. And for the English version, it's been recording right now, currently at the moment. Okay, so since there is a space for these tricky questions, you might see them, might see those topics that I've talked about, like EHRP, BGP, RF, etc. And this series here just to discuss them before you take your online exam. Okay, so back to the question: feasible distance, administrative distance, the successor, the feasible successor. All of these terms are components that define the metric of the EHRP. In OSPF it was the cost, called the cost. In EHRP it takes a lot, much more complicated, but it's completely automatic. Okay, so the feasible distance of one of the paths. Okay, so the topology is this way. This is me and this is my destination. If I wanted to go here, it's either I go from this way or this way. If I went from this way, it will be the feasible distance will be 3072. From the other way, it will be 6144, which means the double. Okay, what do you need to load balance your EHRP routes to make use of both the paths? Something tricky that you might have no idea about for the EHRP protocol. If this topology was for OSPF, you will only send traffic from the best path. This topology was for EHRP, then you can enable something called unequal cost load balancing, UCLB. This will allow the EHRP to make use of all the available paths and enable the unequal cost load balancing. Like if this path has maybe had a speed of 100 meg per second, and the other path had a speed of 1000 meg per second, or 1 gig. What the HRP will do, the HRP only will send a packet from here. At the same time, it will send 10 packets from here. Okay, because this one is 10 times better than this one. So it will make use of both of them. Okay, it will fill them both. If this one is 100, this one was 1000. Okay, thank you both. Thank to both of you, to both the routes, both the paths, and I will send 100 meg from here. At the same time, I will send 1000 meg from here, but it's in packets. Okay, it's per packet, not per flow. Okay, so this operation or this feature, this beautiful feature is applied by using something called the variance V, and this equals the good bandwidth or the speed to the bad one. Okay, to the weak one. This time strong to the weak one. This will give me 10 to 1. It's a ratio. Okay, or maybe this one is 200, this one is only 100, this will be a 2 to 1 ratio. This is the idea. Right now, what you see, the feasible distance tells you the difference in the maybe quality of the two paths, because one of them has a FD of 372, the other is 6144. I'm sorry. So this one is double than this one. So there is a variance of 2 to 1. Okay, so one of paths is twice as better as the other one. So how can I make a load balance between them? It did not mention an equal cost or an unequal cost load balancing. It's a load balance. Okay, just make use of these two paths, please. So I will change my variance for the path of 3072 to make it number 2. Okay, and for the other one it's already number 1, and it will understand that it will be a 2 to 1 ratio. That's it. It will send from both the paths. Okay, so the other options, I do always discuss all the options and then tell you the correct one. Change the maximum path to 2. By default, EHRP does support a lot of paths. By default, you do not need to change anything from the number of supported paths. Change the config so they both have the same feasible distance. I'm afraid you cannot change that easily. Okay, and this is not really preferred. Maybe changing the variance, or that will be good for this guy to become 2. So it will be a 2 to 1 ratio, and both of them will be applied. I will give you just one hint. If your network is not about 4 routers, maybe it's about 40 routers, 50 routers, once you change the variance, the entire autonomous system will be affected. This is extremely important for real live networking, the company that you work with maybe, and in CCNP studies. And by the way, just because I have mentioned CCNP, there will definitely be CCNP in-core, CCNP Enterprise in-core exam course available both in English and Arabic next month. And by next month, I mean few days, okay? It will be in June 2020. I'm working on it, okay? This will be entirely different than the CCNA, a completely new level, okay? So, or maybe 4D, change the IP address so that both paths have the same source IP address. No, this is not really effective, okay? So C will be good by changing the variance. It will make the routers understand it's a 2 to 1 ratio, and we'll send 2 packets from the good one packet from the bad one. I'm sorry, vice versa. Okay? So C will be the answer for question number 1. I've talked a lot actually. Okay, question number 2. Which of the following dynamic routing protocols are distance vector routing protocols? At the beginning of chapter 3 of the complete course that I've already published, I will tell you that routing protocols in the world are either static, like the static route and the default static route, or dynamic. Okay, and dynamic have 2 parts. The external gateway protocols, like only one protocols in the history, which is the EGP. Later it was developed to become the border gateway protocol, BGP. This will be studied a lot and configured a lot in the CCNP course. It was removed from the new CCNA. The other part, or the other half, is called the interior gateway protocols, protocols that you use in your network, in your enterprise. Okay, so the interior gateway protocols are about 2 main families of protocols. Okay, the first one is called the distance vector, like this way, the distance vector. Those guys, or those protocols, cares about the shortest way to reach, or the number of hops that the route will take to reach its destination. Like the RIP, it's a really RIP, it's not a joke. It's a routing information protocol for the real name, but currently it's an RIP. Goodbye. No one will ever use it, not even in the 21st century at all. Okay, it was a very old protocol that was developed and produced in the 1967, and the last update it got was in 1997. And thanks a lot to Cisco that they removed it from the new CCNA. It was really annoying to teach students the RIP protocol and the 3 generations of RIP protocol in the old CCNA course. Okay, and also the other protocol, it's called the HSRP that I've talked about in the question number 1. Okay, I have been talking like for 20 minutes and it still has been only 2 questions, but don't worry, we'll fly in the other questions. So this family of protocols that contain 2 protocols, they care about the shortest path or the number of hops to reach the distance. The other family is called the link state. Those guys cares about the status of the link. Okay, they will choose a very long path just because it's much faster than a short path. Okay, just than a shortcut. Those guys are the OSPF and the intermediate system to intermediate system, the ISIS. One hint is very important, is that the HSRP, as a matter of fact, is considered a hybrid protocol that has half characteristics from the distance vector family, and its other half characteristics are from the link state. But just to categorize it in one family, to give it a last name and its passport, then it will be a distance vector protocol. So who are the guys that are distance vector? They are RIP and HSRP. Okay, so this is HSRP, this is RIP. I'm sorry, oh, this is not RIP. This is RIP. BGP is not here. It's out already. Okay, it doesn't have really that matter of families and classification. It's just an exterior routing protocol. OSPF and ISIs are link state. Okay, so BE will be the correct questions, and that will be if only there was something called choose. This is N double O, choose two in the exam. If there was no such note here, then it's a choose one. It's correct that there are a lot of possible answers, but if it was choose one, then which one will you choose, the RIP or the HSRP? Definitely the RIP, because it's a pure distance vector. If it was a choose two, I don't know, maybe you will face it in the exam like choose two, then you will choose RIP and HSRP. That's it, okay? It will not be choose three, believe me. So it's either nothing, this means the default state, choose one, that will be RIP, and choose two, it will be HSRP. Okay, so that will be BE or only E, depends on your question. Question number 3. I have talked a lot about notes, etc. Let's talk about the questions. If R1 receives a packet destined to this network, 172.16.1.1, which IP address does it send the packet? Okay, so the next hop of this network, let's see who will know this network. Those guys are 192, so all of them will, no, I'm not talking about 172. 192 no, 192 no, 192 no, 192 no. No one has mentioned there are no installed routes that can lead you to 172.16.1.1. So what will happen? Will happen something called the static default route. It will not have a shortcut of SDR at all, but I'm just telling you a name. The static default route, and the static default route is that kind, Father, that whenever there are routes that no one cares about them, no one guides them, he will take them and will route them to its own next hop. Okay, this is the default route. Whenever you see zeros /0, this is a default route. Don't care about the symbol because this is something of the CCNA. It's not really something simple. We'll talk about it later. It might be NS, a D, an O, whatever. Okay, but whenever you see zeros /0, this is the default route. It's not a static default route. It's only a default route, an OSPF default route, but it's a default route. Whenever someone did not mention, whenever there is a route that no one cares about it, no one can take you to it or route you to this destination. This destination. This is not my native language. I'm sorry. So the default route will do it, and this default route will take you at its first station, which will be 192.168.14.4. So yes, whoever wants to reach this destination, then it will first go to this destination and later so on, depends on the other routers. So 192.168.14.4 will be the next destination to this one, to reach this guy. Okay, that will be A. Question number 4. Which two VLAN IDs indicate a default VLAN? Only in Cisco switches, and only in Cisco switches there are some reserved VLANs that are called default VLANs, and I have talked about them in chapter 2 back in the series, and those cannot be changed at all. Like VLAN number 1, this is a reserved default VLAN. VLAN 102, 1003, 1004, and 1005. Those 5 VLANs are not for you, they are for the system, for the switch, so don't touch them. Otherwise, you have almost 4090 VLANs to use, from VLAN number 2 up to 4096. Okay, this is a 9. So, which of those are a default VLAN? There is nothing in the Cisco world called VLAN 0. There is a default VLAN number 1, definitely. 105 is a default VLAN. 106 is just beyond 1005, 1005 or 1005, so it's a normal VLAN that you can use, delete, change, rename, do whatever, shut down, unshut, etc. And also 4096 is a normal VLAN. Okay, so BC are the correct questions that indicates a default VLAN and only in Cisco switches. I have worked with switches that have VLAN number 1 as a default VLAN, but you can delete it. And Cisco, it will be catastrophe. You cannot delete it. Okay, the switch needs the default VLAN to live. Okay. If the router 01 RTR means the router 01 is configured as shown. Which three addresses will be received by other routers that are running EIGRP on the network? Okay, choose three. Yes, it's not your job to study HRP in the CCNA course, but just in case you have faced such question, don't lose its scope. I'm telling you about it because this is a router HRP. This is ASN, an autonomous system number. It has advertised this network, this network, this network, and enabled auto summary, which is a lie because by default it's enabled. Auto summary is already enabled by default in Cisco and routers for HRP. What auto summary will does is this thing. Auto summary means that once you reach your edge router and your edge router uses EIGRP for your network, and this same edge router definitely will use another routing protocol to go for another maybe network, to connect to another network, maybe to connect to the internet, etc. So this edge router contains two protocols, EIGRP and another protocol. Static, directly connected, OSPF, ISIS, BGP. This BGP might be internal or external, whatever. Okay. The idea will be this router will take all the routes, all the EIGRP routes. Maybe the routing table will be this big. Okay. My other hand, this big. Okay. And should change those routes so that this other router, that this other protocol, like maybe it's OSPF, will understand those routes and will inject it to it. The big headache will be to take like 100 routes, different routes, and transform them or maybe change them or exchange them from being, actually it's a redistribute them from an EIGRP to become like OSPF. EIGRP does not do that. What it will do something called route summarization, okay, which is enabled by default in EIGRP. Most of the time we disable it, depends on your network. And basically, without taking this up to 30 or 45 minutes of describing the route summarization, because it has been removed from the CCNA, what it will do is that if you have more than a lot of networks that start with 10, okay, it starts with 10, so it's a class A by default. It will summarize them in one network, which is 10 dot something. Okay, so 1/10 network will express the entire class A, or maybe express the entire, I'm sorry, not class A, the entire tens. Okay, if you have 172 dot something dot 16, I'm sorry, dot something, a lot of it, maybe 10 routes from 172.16, it will summarize them in only one, just like for the 192.168, talking about private IP addresses only. Okay, the idea here right now is that what will this router advertise to the other routers after it summarizes them? The trick here will be is that if you have implemented OSPF, and I hope that you have came here after you have finished the real course, or you have at least studied it from another resource, whatever, but you are already a good student that have studied everything, then you would have implemented OSPF, and in OSPF to advertise a network you will type network XXX whatever with this wildcard mask and area number X whatever. Okay, in EIGRP it's the same, just without the area. So there are some missing things here, which are wildcard mask. What are they? The engineer did not type them. What will happen, because the engineer did not type those wildcard masks for every route and did enable auto summary, the EIGRP will automatically summarize those networks and will advertise their summarized subnet or their summarized prefix, like 10.4.3.0 comes from class A, which is 10.0.0.0/8. Okay, and that is not really good because you did not mention the wildcard mask. Then I will change this and summarize it to this way. So I will express it this way. That will be C. Answer number 1. And once in the 22.16.4.b.4.o comes from class B, which is /16, and this can be summarized to the generic one, which is 172.16.0.0, because this is where it starts from. So this will be this way. Okay, for the 192.168.2.0, this is a class C, And in class C, the first three octets are fixed. All of them are networking octet. Only the fourth one will be the host octet, and I can change it. So this one I will not change it at all, because 192.168.2.0, it will be a class C, it will be a /24, and it will be advertised the same way. So it will be this way. I hope this was clear for you so far, because this will take a lot of time to describe. This is not a really CCNA something, but just in case you faced it, because this is from the old CCNA exam, just in case you faced it in the exam, this is how you answer it and how to know what an auto summary is. Okay, otherwise, it's either you are a CCNA 100, 200, 125 student, or in the CCNP Enterprise Core. In core exam, there will be a lot of talking about this subject of the summarization. Okay, for question number 6, which two options are the best reasons to use IPv4 private IP addresses? Number 1, to enable intra-enterprise communication, definitely, because I can only use private IP addresses inside. Number 2, to implement NAT. This is not really a good thing, because I can use the public addresses without NAT at all. Number 3, to connect applications. This is not really a layer 7 application something, or an API. Number 4, to conserve global address space. Yes, to avoid exhausting or consuming all the addresses in the world and duplicating the private IP addresses inside every enterprise or every company. And E, to manage routing overhead. Not really, not quite really. Not about this way. Okay, so that will be A and D for question number 6. For question number 7, which technique can you use to route an IPv6 traffic over an IPv4 infrastructure? What do you mean by that? I mean, if I have a server in my country that caches Google's traffic or Facebook's traffic, which is a CDN traffic, and this servers use IPv6, it will be connected to my router and to my edge router. My edge router will have a public IP address, which is an IPv4, that connects to Facebook's edge router, which also uses IPv4 address, maybe this way from here to here, and their server inside their network is also using IPv6. So I will need to route some IPv6 traffic over an infrastructure that is using IPv4 address. What should I do? It's either you use NAT on both these routers, and it's called NAT 64. So whenever you receive an IPv6 here, it will be NATed to an IPv4. Goes here, NATed to an IPv6. Go here, and vice versa. Yes, there is such thing. Or you will use a 6 to 4 tunneling, which is creating a tunnel starting from this interface to this interface. It will be a pure IPv6 tunnel all the way, and manipulating this path without it knows what's happening. And there is also a 64 and NAT 64, and there is one third way that I have forgotten, unfortunately. But from the possibilities here, I have 6 to 4 tunneling. Very good, very good. That's very good. The normal NAT is an IPv4 pure. This is a private to public. L2TP, this is for VPN. This has nothing to do with that. Dual stack is enabling both IPv4 and IPv6 all the way. So making your server have two addresses, an IPv4 and IPv6. Making your router having two addresses, and also this one and also this server. So you'll have either IPv4 and IPv6 all the way. This is a dual stack. This is an application of IPv6. This is not really a technique to manipulate the 6 over 4. Okay, so B will be the only correct answer for today for question number 7. For question number 8, which 3 describes the reasons large OSPF networks use hierarchical design? What do you mean by hierarchical design? It means that I can have this region uses OSPF process ID 1, this region uses OSPF process ID 2, this one uses OSPF process ID 3. Inside every region, there will be the east side, west, north, central, south. Each one of them will be area 0, area 1, 2, 3, 4, and so on. Okay? So the idea here, why it's really that hierarchical, that's it having the process ID and underneath the area, will be number 1, to speed up convergence. that will be correct. Why? Because if you have a network of 300 routers all connected together, and one route receives something and want to advertise it to, it will say, I'm connected to other 300 router. Let me calculate that correctly in detail. This will take seconds. This is a disaster. By doing this hierarchical thing, each router will be maybe like isolated in its process ID inside its own area. Maybe inside this area there is a maximum. Actually, it's only designed from a perspective of designing. You can inject up to 50 router per area. And this is the maximum accepted number of routers inside an OSPF area. It was a 50 router, I believe. Okay, so that's it. It's a maximum 50. That will be much better than a 300. So the router will do a faster decision to route. This is number one. Number two, to reduce routing overhead. This is almost the same thing. Reducing the overhead means a faster convergence and using less resources like CPU and RAM. To lower the cost by replacing routers with distribution layer access, layer switches. This has no sense to discuss. This has no idea. To decrease latency by increasing bandwidth, uh, dividing routers or maybe isolating routers in areas has nothing to do with bandwidth. They have the same ports, same suites. To confine network instability to single areas of the network. Yes, because when you have an issue with area number one, only area number one will be affected. Area number zero will operate normally. Area number 2, 3, 4 will operate normally. That will be good. And to reduce the complexity of the config, actually it's not. Why? Because when we have studied and implemented OSPF to advertise networks, it was network XXX with the wildcard mask YYY, area X, maybe 0, 1, 2, etc. So if you have a router that has 4 interfaces, 4 networks, each one of them to the same areas or separated areas, you will always advertise 4 networks. You will just change the number at the end. It's either area 0, area 1, area 1, area 2, that's it. So this is not reducing complexity. The same lines are being used to advertise networks, whether it was single area or without areas, okay? So ABE will be definitely the 3 correct answers for question number 8. Okay, you need to run speed up a bit. Question number 9, which statement describe OSPF? It supports VLSM. Yeah, it supports VLSM. What do you mean by VLSM? Classless IP addresses. Classless IPv4 addresses. It supports something called /25. Yeah, /26, /30, /19. Definitely. Okay. RIP version 2, EHRP, and OSPF v2, all of them supports VLSM. It routes between autonomous systems. No, only BGP and EHRP do that. OSPF does route between areas. It confines network instability. This is the same as the previous question, so it's correct. It increases the overhead. No, it decreases the overhead. We have discussed that. It allows extensive control of routing updates. Extremely correct. And this is why OSPF is number 1 and has beaten EHRP. Although EHRP is much faster, but OSPF gives a lot more flexibility and control upon your routing. And it's simpler to configure than RIP. No, because in RIP you say network 10, network 172, network 192 and go, without any subnet wildcard mask, without areas, without a process ID at all. Okay, so this is definitely incorrect. So A, C, E will be the 3 correct answers for question number 9. Question number 10. Which command should you enter to view the error log of an EHRP? Use some error that might have happened before on the EHRP IPv6 environment. Show IPv6 EHRP neighbors will only show you the direct connected neighbors. This is not about errors. Show IPv6 EHRP topology will show you the entire number of routers that are connected to me. Yeah, this is a correct command that's already available in EHRP, but this will not be useful to show the errors. Show the traffic will not show you errors. Show IPv6 EHRP events will show you all the events and logs, including the error log. So it will be D. Okay, and I hope that it is okay. Hope that my language, accent, and voice are clear too. I'm sorry it's not my native language. I'm working on that a bit. Okay, so which component of an Ethernet frame is used to notify a host that traffic is coming? A host is a PC that is connected to a switch, so they are always 24/7 sending electrical signals between them, full duplex going forward and backward. What is the element that a frame sends from the switch to the host just before traffic starts to come? This will be the preamble. Okay, this one. C. The type field and the data field, both of them are components of the real data that will come to you from inside that traffic, not before the traffic, inside the traffic. This frame delimiter, I have no idea about it, but it's incorrect regarding this one. Preamble will be the correct one. Okay, question 12. Well, which command must you enter to guarantee that an HSRP router with a higher priority becomes HSRP primary router after it's reloaded? First hop redundancy protocol family has been removed from the new CCNA, unfortunately, to the new CCNP. It's included in the CCNP enterprise course, but it was in the CCNA. It was a family, actually. It contains HSRP for Cisco only, which is this guy, VRRP for all the routers in the world, and GLBP for Cisco only. Okay, so this one will not be our talk. What HSRP does is that at the edge of your network, you have a switch, probably a multi-layer switch, that's connected to a router. This router will go to the internet. If this router fails, you have no internet. So the solution will be to have another router that's connected to the switch, and at that time, what will your devices have their default gateway assigned to? This one or this one? Because one of them must be their gateway so that they will go to the internet. HSRP will virtually create a third router that you cannot see, and it will reside virtually in both of them, and the IP of this virtual router will be given to the PCs. So PCs will go this way. Once it's done, or maybe once it's down or out, it will automatically see the same virtual IP address is also available in the other router. So it will take the backup one and go. So by default, there will always be an active and a standby router. One of them is being used, the other one is expensive, cool, clean, but will just wait for its turn to come. A substitute player that might not leave the bench for the entire season. Yes, like a lot of players, a lot of poor, expensive players that leagues are buying and clubs are buying, but it's not being used. Okay. The idea of the question is saying that if this one fails, the traffic will go this way. Once this one got fixed, what will guarantee is that the traffic will draw back and go again, resume streaming from the main one, and this standby comes again a standby. This is an option called preemption. And lab number 3 in the Mega Lab series will be all about HSRP. Will be extremely important and beneficial for you because all networks uses FHRP, whether it was an HSRP or VRRP or GLBP, and all of them have the same config and commands almost. So it will be very important to an engineer to know how is that happening and working. And since it was removed from the CCNA, I did not mention it in the course, but I will mention it in the Mega Lab because it's an extra course. Okay, it's like a CCNA plus. So the preemption command will enable the negotiation between two routers to always detect, hey, you should be the main router. Are you? If you are not, then you go to the main router right now. I will go back to become a standby. Each one will know its own role. Okay, this is like Benzema. Okay, so this is for question number 12. For question number 13, which config command can you apply to an HSRP router? Again, I believe it should be an HSRP. Yes, it's exceptional. Router so that its local interface becomes active if all other routers in the group fail. The same idea. We have two routers. This is the entire network that you have. If you are wondering that this is a single point of failure, no idea of having two expensive routers if they were connected to one switch and when that switch fails I will lose internet. Yes, that's correct. It can be modified later, but the idea of HSRP is adding routers, not switches. Okay, so what will I make to this interface? I'm sorry, to this interface, which is a standby, and this one is the active, so that when this one fails, this will automatically becomes inactive. If HSRP is already applied, then the uh, this is how HSRP works. This is the role, or this is the application of HSRP. You should do nothing, okay? Because you should not track an Ethernet as long as it's in the same domain, and you should not enable preempt. This is making the standby active, not vice versa. And this is not changing priority because they already have priorities configured. This question is about if HSRP was working normally. What should I implement later or further so that the standby will become active only when the active fails? Do nothing. This is the normal operation of HSRP. And you will see the simple commands of it in the Mega Lab series. Okay, 14. You are configuring your edge router, which is connected to the internet with a public IP address, definitely internet. The router needs to obtain IP address from the service provider. So this is your network that is connected to an edge router. The edge router is connected to the internet through a service provider. What you need is that this interface, which is fast Ethernet 00, this one, should obtain a public IP address from the ISP. This is based on the contract that your enterprise company signs with the ISP, that they give us a public IP address or provides us dynamically with a public IP address. Okay, so there is a lab that I have already done in the videos of the April package of this series exam prep. And in this lab that you will find that when I enter to this router and make this interface with the command of IP address DHCP, it will ask the opposite side to please offer an IP address. Okay, and just in case there was a DHCP server here, it will reply to it. So you will need to enable the command IP address DHCP on this interface of a router. Yes, of a router, not a PC, not an end device, to take IP address from the opposite side. That will be D. Question 15. Which type does the port become when it receives the best BPDU on a bridge? This is for chapter 2, switches and VLANs and spanning tree. If I have my switch that is connected to some sort of switches, whatever the switch is, 24/7 there will always be on the hour, on the go, there will be some non-stoppable type of messages exchanged between switches. A unique type of languages that only switches speak, which is called the BPDU or BPDUs. Okay, this is a special messages that is exchanged between switches. It has some types of BPDUs, BPDU, BPD guard, a lot of types. One of them is called a best BPDU, or it's called a superior BPDU. Superior BPDU. It has the same meaning. This type of BPDUs, my switch will only receive it from the root bridge. And once my switch receives a superior BPDU from whatever switch in the network, it will know that that guy is the master here. This one is the root bridge because it sent me a superior BPDU or a best BPDU. Okay? So whenever I receive a message from another guy, then I know that you are a root bridge. And for the port roles, regarding the port roles, for this question, just like I have discussed in chapter 2 previously, whenever there is a root bridge, then all its ports are designated ports, and whenever you see the designated ports of a root bridge, on the other side you will see a root port, which is the port that leads you to the root bridge. Okay, so which type does a port become when it receives a best BPDU? So my port, what will it become? It will become a root port. D. Okay, designated will be your switch. Backup and alternative will be for blocking. Okay, alternative, yeah, backup and alternative will be for blocking, and one of them is for RSTP. Yep. So question 16. Which two commands or command sequences must you configure on a switch to establish a layer 3 ether channel with an open standard protocol? This is rubbish. This is not useful. Why? I will tell you why. And at the end of chapter 2 I did mention that. If you have two switches that are connected by using more than one physical port, then you will need to enable layer 2 ether channel because they are switches, they are layer 2 devices. And to enable layer 2 ether channel, it's either to use an open standard protocol that is LACP, which have the commands of active and passive, or to use a Cisco proprietary protocol which is called PAG-P. So in this way, capitals and this small g. Okay, port aggregation protocol and link aggregation protocol, control protocol. Okay, so this guy uses the desirable and auto modes. This one uses the active and passive. But for layer 3 ether channel, there are no negotiations, no LACP, no PACP. There is only one single mode that's called on this side, on this side. Layer 3 is guaranteed. Okay, so on these commands you will see that this one, interface X channel group 10 mode on. This is for layer 3 ether channel, correct? This guy is active, so you'll be a LACP. No, this is a layer 2. This one will be auto, which is this guy. For PACP, this is a layer 2. This is a trunk. No, trunk is a layer 2 command, okay, because this port should be a layer 3 port later, because it's a layer 3 ether channel. And no switch port with specifying an IP address will definitely make this interface a layer 3 interface from both the sides. Okay, so A for enabling that, E for turning it from a switch device to a layer 3 device. You might wonder, when will I see a layer 3 ether channel if they were switches, if they were multi-layer switches, so they support both? I have talked a lot about that in the first two chapters. Okay, chapter 1 and 2. Question 17. Let's see how much we will take today. Which statement about VLAN config is true? Number 1. The switch must be in a VTP. This topic has been removed, but I've discussed it in the April package. The switch must be a VTP server or transparent mode before you can configure a VLAN. Yes, that is correct. The switch must be in a config mode before you configure an extended VLAN. This is way beyond your study, but it's incorrect. Dynamic inter-VLAN routing is supported on VLAN 2 through VLAN 4064. What happened from 65 to 96? No, this is not correct. Dynamic inter-VLAN routing means the ROS and SVI that you will find them in the Mega Lab, which also has been removed from the CCNA. BTP has been removed from the CCNA. This question should be removed from the CCNA, but it depends on your luck. A switch in VTP transparent mode save the VLAN databases to the running config. What about the startup config? Is it prohibited? This makes no sense. The meaning of A is that it's preferred as a best practice is that you have your switch and you make it a VTP server or a transparent, make it a VTP server first, and then configure some group of VLANs with their own names inside it. What will happen later? This guy will automatically update all the other switches in the network with those VLANs, so you will not need to log into the other switches and configure the same VLANs with their same names again. This guy will do it for you. This is the only benefit of VDP, the only benefit, and it was removed from the CCNA. Okay, and was not even placed in the CCNP because it's not that useful actually. Okay. After you apply the given config to a router, this config to some router, the DHCP client behind the devices cannot communicate with hosts outside of their subnet. I have this host, maybe a server that is connected to a router. The router has some some config, but this server, after this config is done, is unable to go this way beyond. Okay, which action must you apply? So it's IP DHCP pool and has the name of this. It has a name of this. It has this network with the subnet mask, no problem. Some domain name, DNS server, main and backup or secondary DNS server, no problem. some other dominate BIOS name server, also I'm sorry, also two servers, and no problems. But this router is providing this server with a network, a subnet mask, and some optional informations. Where is the gateway? Where is the command default router 192.168, maybe 10.1 or something, 10.10 or whatever? Okay, we did ton of DHCP before, because, and also did the mega lab. So there is no gateway. This guy is not receiving a gateway, so doesn't even know how to reach this interface so that the router will guide it to the other interfaces. So you'll need a DNS server of the same subnet. No, I need to activate the pool. It's not a real test pool, it's just the name. It's already activated. Correct the mask. What about the mask? It's good, but at least configure a default gateway, please. Just like I said, D. Okay. So that will be D for question number 18. 19. Refer to the exhibit. How will the router handle a packet destined to this one? Look, you might see up to 6 questions of routing or forwarding decision in the exam. You should not fail any one of them, or you should not do any mistake, because they are very logical, very simple. And you will also see up to 6 or maybe 8 questions of subnetting and subnet masks and podcast IDs in the question in the exam. Also, those we should not lose points with them, because those are real fundamentals. Those are really the ABCD of networking, and you should take their complete score. Okay, should score all of them correctly for the forwarding decision and the subnetting. So the idea here is that which one of those routes will lead you to this network. Whenever you see tens have nothing to lead to 192.0. 192.168 is greater than this one, so it's beyond it. This one is also, I'm sorry, this one is also, okay, so none, but unfortunately there is a gateway. The term gateway of last resort in a router means the default route. So there is a default route for this router, which will be kind enough to handle this packet, because no one wants to do that. No one wants to share some good things. All of them are specified in their own subnets. No one mentioned this specific subnet that starts with 192.0. So this kind guy will do it, which is the default gateway, which is the last resort, and its next hop is 192.168.4.1. Okay, so this router is connected to a router, and this other router has this interface, or maybe on this route here, 192.168.4.1. The default route will be through here. Whenever someone is unknown, it will be taken care of and sent from this way. So the question is, which interface will that be? I don't know, but I can see that this interface here, which is 4.0/24, so 4.1 is included, goes through serial 0 and serial 2. Okay, so serial 2 will forward this, because it's forwarding the default route, and the default route will take care of this one. That will be C. Yeah. I'm sorry, where's the mouse? Yeah. So 1920, we are almost done for today. I have crossed 1 hour, almost, yes. Which unified access point mode continues to serve wireless clients after losing connectivity of the controller? By default, none. This is my access point. I have talked a lot about this question in chapter 6 when I was talking about wireless networks. And this is my wireless controller, the WLC, and my lightweight access point. They are connected together somehow through some multiple switches in the way, or maybe the routers. And there is a virtual two-way tunnel that's called the CAPWAP tunnel. Okay, that connects both the access point, every single access point, with its own controller. This guy does no decision at all, and do not decide, don't do anything, don't do yes or no without the permission of the controller. I've talked a lot about that in chapter 6, and once there was an issue that caused the CAPWAP to drop, This one is not allowed to do something in the absence of the control. So what it will do is that it will disconnect all its wireless clients, because I'm sorry, I cannot serve you if my master is not here. Whatever it says I do, and since it's out right now, out of reach, so I can do you nothing. This is a disaster. This is the local mode, okay, the default mode of Cisco access points. It was fixed later by adding an operational mode called Cisco Flex Connect, only for Cisco access points. This one will save some information that are already taken from this guy, and when something happened to the cap op, it will continue operating until the cap op gets fixed and later gets updated. Okay, so this will be Flex Connect, and it's definitely mentioned in chapter 6 more than one time. Okay, so what AD has a route to this destination? Let's see. 192.168.12, it starts from 12, so bigger than 10, no. Starts from 13, it's beyond. Starts from 14, it's beyond. Starts from 10, yes, matching, thank you. But it doesn't have a destination because this is a general summarized network that inside it there are some small networks. I care about them. So it's either 192.168.10.0/24, this one includes it, so this is a possibility, or .10.32, 32 is bigger than 1, so it's beyond it, I'm sorry. 192.168.0.0/16, it includes it, but it's much bigger, and the longest match term is much lesser here, because we need a smaller subnet masks, a more specific subnet mask that will route to this destination. So since 24 exists, I'm sorry, you are useless for me right now. There is also 192.168.10.1 typical /32. This fits 100%. It matches 100% the required destination. So it will be much more preferred than this one. So I will use it, and nothing is more preferred than a /32. And by the way, whenever you see a /32 in the routing table, it's called a host route. It has a specific, very important name, which is a host route, not a network route. Okay? We will have another question later saying that the same topology, the same addresses, but just saying which type of routes will handle it. You will see /32 works, you will choose a host route. And other informations are like static route, default route, dynamic route, network route, etc. Okay? You will see the same questions, maybe the third time with maybe the same addresses, but saying this time which protocol will do it. So we will come, the longest match wins, as long as there are some differences in the mask, and this guy wins. It has a D, and D according to the legend is HSRP, so we will choose HSRP. See, same question with the same IP addresses and information, but a trick in what the question is asking, or how to choose the answer every time. Okay, that's why I'm saying that the forwarding decisions and subnetting, you should never make mistakes with them. You should take a 100% score of it. So since this one wins and it has a symbol of D, which is EHRP, and EHRP has an AD of 90, all of them are written in front of me, so it will be 90. Okay, this is for question number 21. Good. 22. Yeah, good. Which command would you use to configure a static route on R1 to route to this network with a non-default AD? The default administrative distance of static route is 1. Just do the static route to this destination, but not using 1. Use 2, 3, 4, whatever number, just not 1. Okay, so it's IP route to 192.168.202.0, that's correct. This is a /24, that's correct. This is a destination, whatever, that's correct, but it has an AD of 1. This is the default. I need to use a non-default. I'm sorry. Go away. Again, same route, which is correct, just like the question wants, the same subnet mask, the same destination, with a different AD, which is non-default, that is definitely correct. The third one will be adding the administrative distance in the beginning those are not correct commands of the static route. It should be at the end. Okay, so B will be the only logical and acceptable um, answer. Which feature or protocol is required for an IPSLA service level agreement? Definitely a CCNP protocol that I will talk a lot about to measure UDP jitter. What is jitter? It was in a CCNA voice, and it will be in the CCNP enterprise because it's the main component that needs to be discussed whenever quality of service is there. Okay, jitter is having a non-stable delay in the communication and connection between your phone and some other guy's phone while you are talking on a call. So that will be the robotic sound that you hear whenever you talk to the other guy. This is called jitter. So we need to measure jitter on the UDP. UDP is definitely calls. Voice and video calls are UDP always. They are never TCP. So which protocol for an IPSLA to measure that jitter? LLDP and CDP are for neighbor discovery. Embedded event manager are for whenever something happens inside a router or a switch. Measure it and take a decision to do some script at that time. This will have a lot of discussion in the new CCNP. It has been added to the CCNP, and NTP ES2 serves in synchronizing and measuring the jitter. Yeah, because it works a lot with QoS. So network time protocol is correct regarding question number 23. 24. Which effect, there should be a C here, does the AAA new model config command have? A AAA new model config is a set of lines that you should enable by default. You should enable whenever you buy a new router or a switch. This is to tell your device how to communicate and whom to communicate regarding AAA config. This server with these authentication and this password and IP, etc. So this is just to enable the AAA services on a device and to contact someone. So it configures a device to connect to a radius server. Why not to a TACAX? And it associates a radius server to a group. No, a group, not ungroup. And configures a local user. This is definitely not correct. Okay, local is local, not AAA. AAA remote decision, local is local. Okay, so it's for enabling only the AAA services on a device. 25. How will switch 2 handle a traffic coming from VLAN 10 on switch 1? This is switch 2. This its interface that is receiving a frame from switch 1, and this frame has a tag of VLAN 10. So the config will be interface fast ethernet 00, which is this one. It's access to VLAN 5, I don't care. Interface fast ethernet 01 for me, destined for me. This is a trunk allowing VLAN 5220, and the native VLAN is 10. So VLAN 10 will be sent to me untagged because it's a native for him. So I will receive it untagged and I should forward it maybe everywhere. I will not limit it. For my config, let's see. Also for fast ethernet 00, it's access for VLAN 5, yeah. But for fast ethernet 01, it's trunk 5220 and it has a native VLAN of 100. So there is a native VLAN mismatch. And in that case, unfortunately, since the native VLAN mismatch, so this broadcast domain have some untagged frame that moves freely differently than the other broadcast, there will be a different thing. Okay, it will be a native VLAN mismatch, and that will cause a communication problem between them regarding this frame or this VLAN. So it will drop the traffic. Sorry. Yes, because they should match between both the devices. That will be C. Okay, question number 26. Which two commands can you use to configure and actively negotiate Ether channel? Actively negotiate. What does it mean by actively negotiate? You remember the protocols, either LACP, which uses either active or passive, and pack P. I've talked a ton about that in chapter 2, but anyway, which is either desirable or auto. What is the difference between active is a very aggressive guy. Whenever you make a port an active, it will immediately identifies itself, say hi, my name is X, I would like to make ether channel with you, just like this way. Okay. Ambush. Not ambush, not ambush. Ambush is an extremely different word. I'm sorry, this is not correct word. Anxious, or maybe like a rush, on a rush. Okay, just want to make an ether channel relationship with the opposite side. This is the active. And this word is called desirable. The same role, the same action. Okay. The passive and auto are sleeping and shy and will never establish a negotiation or start a chat with you unless you ask them, and they will say, yeah, definitely, why not? Okay, so you will need an active and a passive, you will need a desirable and an auto, or you will have two actives and two desirables. It can work. So who are the active guys? They are the active and the desirable. Okay, the passive is sleeping, the auto is sleeping, and the on is not a negotiable ether channel. It's not about negotiation. It's just enable for layer 3. So that will be D and E for question 26. Question 27. I hope that you are not bored. What is the binary pattern of a unique IPv6 unique local address? Unique IPv6 local address starts with FC00 /7, and just in the blueprints and in the documents of this address it says that the first 7 digits are created by 4 ones and 110, the first 7, and the rest are zeros, etc. Okay, and that's also related to /7. So it starts with 6 ones and a 0. So whenever there is a 6 ones and a 0, etc., this will be the binary pattern of FC00::/7, which is the unique local address of this one. Okay, so this is just a quick question regarding have you read the book or you know such extra questions or not. And that's it. Okay, for today, yeah, that's a lot. That's more than an hour of talking. And that's it for today. I hope that it was beneficial, good for you, not a lot of headache. You can see that about 80 or 85% of the questions here are already mentioned in the course. Just because there might be some questions that are not mentioned in the course, tricky enough that you will see in the exam, you might have no idea about them. The series is here, okay, to help you with that. So I hope it was informative for you. The comments space is always available below the video. Comment whatever you like. The slides for this video, just like every single slide that I have ever created before, there will always be a download link for the PDF of this slide below in the description of this video. So thanks a lot for watching, and I hope to see you in the upcoming video. Goodbye.